All right, everyone, so we're going to be talking about payout annuities. A payout annuity is basically when you have an account where interest is accumulating and adding to that account. So it's increasing the balance. The interest is increasing the balance. And at the same time, each time period, the balance is being reduced by either if it's a retirement account, it could be your monthly withdrawals. If it is something like a loan, it's going to be your monthly payments. But basically, you're doing something each month where you're removing some amount from the balance while interest is increasing the balance. You can compare this to last video for savings annuities where the interest was increasing the balance, just like a payout annuity. But you each time period are adding to the balance as well. So a savings annuity, the interest is increasing the account balance and you are increasing the account balance by depositing money. A payout annuity, the interest is still increasing the account balance, but you are decreasing the account balance by either withdrawals or payments, or it kind of depends on the context. So we have a formula just like we did with a savings annuity. It's kind of similar, but it is different. And I actually see a mistake right here that I'm going to fix. Okay, so for a payout annuity, we have that the original balance, so for instance, if this is a loan, it's going to be the original balance of the loan. It's your starting balance, or it is when you retire that amount, that lump sum that you have that then you're going to start making withdrawals on. And that brings me to this D is now going to be your monthly, it's your monthly activity. So it's either withdraw if it's a retirement account, or it could be your monthly payments. And then we have R, which is still our annual interest rate. Our N's are still our number of compounds per year, and basically how many times we're having activity each year. So, and we're assuming for this account, we're assuming that the interest accruing and the timing of your deposits, or not deposits, your withdrawals or your payments are going to be the same. So if it's monthly for both of them. If it's daily for both of them. We're not going to have like monthly payments and daily interest for compounding. All right, so this is our formula. And we can actually still use that TVM calculator for these problems down here. Make sure that for quizzes and tests, you know the formula and you can use the formula, but after you're comfortable with the formula, you know the formula, it's all good, then you can go ahead and use that calculator. And probably later in life when you're doing financial planning, you're probably going to pull up that calculator, not these formulas. But okay, so we have our first example. Suppose you want to save enough money for retirement to be making $4,000 withdrawals each month between the ages of 65 to 90. So we're assuming that in this example, we're assuming that like by 90, either that's going to be end of us needing to have money. We're going to assume the account has a 6% interest rate. And we want to figure out a couple of things. First, how much do we need to save up? We want to figure out what the total payout is. I'll discuss what that means when we're solving for it. And how much interest we accrued over the 25 years. So that's going to be like a comparison between how much did we put in versus how much did we get out. FYI, how much we got out is going to be the payout. All right, so we can set up our formula for this. We're trying to figure out how much we need to save up, which is going to be our principal balance. So we don't know what P is, but we know that our monthly withdrawals are going to be $4,000 each. We're going to multiply that by 1 minus, and we have this 1 plus R is 0.06, N is 12, raised to the negative N is 12, times the number of years. If we're going from 65 to 90, that's going to be 25 years. And then we divide this entire thing by 0.06 divided by 12. Now, I will say from my experience teaching this class, last semester, students will set everything up correctly here, but then they'll struggle when they're typing it into the calculator. So I would highly suggest that you get out a scientific calculator real quick, not your phone calculator, like an actual scientific calculator, like you're going to have to use on an exam, and make sure that you can get that this comes out to this number that I'm writing right here. So $620,827.46. So basically, this is the amount that we need to save up in order to support those $4,000 per month withdrawals for the next 25 years. All right, so the next thing it's asking us is, what is the total payout? And the total payout is basically how much are we getting from this account. So we have to have this number we just found, that original amount in our account, but as we're making these withdrawals, that amount is still increasing with interest. So we're getting more than what's actually listed here. And the way that we can figure out our total payout is by looking at our monthly withdrawals, so $4,000, and take into account that we're doing this each month. That 4,000 times 12 is going to be the amount that we are getting each year, and we're doing that for 25 years. So we multiply all of those together, and that actually gives us $1,200,000 is our total payout. So that's what we're getting out of this. So we saved up about half of that, and we're really making like double what we ended up saving up, right? And then from this, I'm going to kind of squeeze this in here. So let me move this up just a little bit. The interest that we earned on the account is just going to be whatever the total payout is, subtract the original amount that we had saved up. And so we made over $500,000 in interest over the 25 years that account was sitting. So that's kind of cool, right? All right, so next, suppose we want to save up for that situation that we just figured out, right? We're like, hey, that actually sounds like a pretty good deal. Let's try to save up for it. And say we're going to be doing that saving for the next 40 years, right? Well, this, now that we know the amount that we need in the account and the interest rate and the time that we're doing it for, this is now a savings annuity problem. So we can solve this problem using the savings annuity formula. So we know that we want to save up this guy. We don't know what our monthly deposits are going to be, so we put D. And then we fill in our savings annuities formula. Right? And if you watched the last video, you would see that we can solve for D here. We end up getting D is equal to $311.74. So basically, if we can budget that we're putting that aside each month into that account that's earning 6% interest, we'll be able to save up what we need so that when we retire, we'll have 25 years of basically having $4,000 a month that we can just kind of pull out and use. And I just want to make a couple notes here. We might be interested in thinking about, well, how much did we actually invest to support this situation. So we would be making these payments of $311.74 for 40 years, which is the same as 480 months. Just take 12 times 40. And we end up getting that we invested $149,635.20. And over the course of that saving up, why am I writing A? We earned, if we just take the 620,000 blah 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 and subtract off the 149,000 blah blah blah, you'll figure out the interest that you earned, which is $471,192.26 in interest over the 40 years, right? So that's cool, right? All right, next problem. Let's say, now here we're going to have a loan problem. We owe $5,500 on a credit card with a 29% APR, so that's our annual interest rate. That's like advertised on our statements and stuff. We want to compare our monthly payments and total interest paid. If we plan on paying this amount off in, our first option is 6 months, 24 months, or 36 months, right? So half a year, 2 years, or 3 years. And I'm going to go ahead and do part A by hand. And I'm going to suggest that you try the TVM calculator. For B and C, just to practice using it and make sure that you know how to use it, because I'm telling you in the future that's what you're going to do. Because really, when you're trying to do financial planning, this is the type of thing that you're probably going to do when you're looking at your debts, and also when you're saving up. You're going to be looking at, okay, what are my monthly payments or monthly withdrawals? Because that's important, right? You need to be able to afford your monthly payments. But then you're also going to care about, well, how long am I doing this for? How much am I actually spending? How much excess on top of the loan am I spending? And you're going to kind of weigh what's going on, right? So for part A, this is a payout annuity. Our original balance is starting at $5,500. We're trying to figure out what our monthly payments should be. And we can fill in the rest of our payout annuity formula. So 1 minus 1 plus, our interest rate is 29%, so 0.29. Divide by 12, because we're doing monthly, times negative 12 times, now here, be careful. We're dealing with 6 months. T is in years, so we're going to have a 1/2 right here. So it's half a year. And some people will put 6 there. It's not 6 years. It's half of a year. And then we divide by 0.29 divided by 12. And then we can solve for D, right? And similar to the savings annuity, we just multiply by the 0.29 divided by 12 and then divide by this chunk in the brackets. And we go through that process. We'll end up getting D is equal to, if you rearrange stuff at a point, you'll get 5,500 times 0.29 divided by our 12. And then the stuff in the brackets, if you type that into your calculator and round, you'll get 0.1335. That's rounded. And then when you type this into your calculator, now that it's a little bit more, manageable, you'll get that your monthly payments will have to be $995.63. Which here, if you were doing your own financial planning, you might be like, well, I can't afford that each month. Or maybe you can. I don't know. But here's where you'll kind of have to weigh, can I actually afford that? If you can afford it, you might be interested in how much am I actually paying. So we can look at our total paid. Whoops. And for that, we'll just take our monthly payments, 99563, and we'll multiply by however many times we're making that payment, right? Well, these are monthly payments for 6 months, so we can multiply by 6. And we end up getting that the total that we pay is $5,973.78, which means that our interest is going to be equal to, we'll take our total paid and we'll subtract off the original loan amount of $5,500. So we'll end up getting $473.78 is the interest that we end up paying, right? Basically, that's the amount of money that we're paying for telling the bank, like, hold on, let me carry this loan out for a little bit and make payments and not paying it right on the dot. Okay, so the other two examples, I would suggest that you pause the video, go and use the TVM calculator and see if you get the same results as I do. So for part B, if we pay it off in, this one was 24 months, you'll end up getting that your monthly payments are $304.70, which means that your payout, or the total that you pay, is going to be $7,312.80, which means that the interest is going to be $1,812.80, which clearly is higher than the interest that you paid if you paid it off in 6 months, right? We're paying between 4 and 5, 4.5 times the interest as 6 months. And then part C, we have that our monthly payments would be $230.48, that our payout, or the total that we end up paying, is $8,297.28. And the interest is $2,700.97.28. So we can compare these. You'll probably be interested in comparing the interest, right? Basically, the longer that you take to pay off the bill, the more interest you're paying. But the smaller your monthly payment is going to be. Basically, what I would suggest for you is when you have a loan, find a monthly payment that you can afford and do the highest that you can afford to do. Because then you'll end up paying less in the long run, but then you know that you can at least afford it.